Today we're starting Chapter 2, Polynomial and Rational Functions. This video is going to cover Section 2.1, and Section 2.1 is all about complex numbers. Complex numbers will include imaginary numbers in them. That's what makes them complex. And today we're going to be performing most of our basic operations with these complex numbers. So let's go ahead and get started. Before we can start actually performing the operations, we need a couple reminders about what a complex number is. The first thing we want to review is imaginary numbers. Now, the imaginary number I is defined as the square root of -1. I know it's a little crazy. We don't normally take the square root of negative numbers, but in this case, if we're going to take the square root of a negative, we're going to instead use this I. Now, I squared is going to equal -1 because if you square both sides here, I squared equals -1. A complex number is just a number that has a rational part and an imaginary part, or a real part and an imaginary part. For example, 5 plus 2i would be an example of a complex number. It has both a real number 5 and an imaginary part 2i. Now, if two complex numbers are conjugates, it just almost means that they're opposites. The sign's in the middle. So 5 plus 2i and 5 minus 2i would be what we call conjugates. So, let's go ahead and start doing some operations with these complex numbers. Number 1, we're adding two complex numbers, and really you can just think of it as combining like terms. So we're going to add 5 and 7, and we get 12. And -11i and positive 4i is -7i, and that will be our final answer. Moving on to number 2, we're subtracting. Now, we want to remember that we're going to distribute the negative sign just like we would if we were combining like terms. So we're going to have -5 plus I plus 11 plus 6i. And now it's a question just like the previous one. So go ahead and take a second and combine like terms. Hopefully you came up with 6 plus 7i. Question number 3, distributive property. We're going to distribute the 4i to both pieces. We get 12i minus 20i squared. Now that we have an I squared involved, we have to do a little bit more work. Remember from earlier, we said I squared equals -1. Okay, I squared equals -1. So I can switch that I squared to be a -1. And -20 times -1 becomes positive 20. So this simplifies to 12i plus 20. And in number 4, we're multiplying here. So we're going to want to go ahead and multiply. We can use our rectangle or foil. I'm going to go ahead and multiply with the rectangle. So let's go ahead and draw one. I'm going to put 7 minus 3i here and -2 minus 5i there. Go ahead and pause your video and try this rectangle on your paper. And when I did this, I got -14 minus 29i plus 15i squared. But again, we're not quite finished. We have to do a little bit of simplifying. Positive 15i squared, well, I squared is -1, so that's going to turn into a -15. If you want to see that again, we're going to do 15 times -1. That's where we got the -15 from. -15 and -14 can combine to be -29, so we get -29 minus 29i. Let's go ahead and look at another example. This time we're going to be dividing. Now, there's not a lot of work to do right here. There's no common factors to pull out and cancel. So instead, we are going to get rid of the I in the bottom. Just like square roots in the bottom of fractions, we don't want I's in the bottom of fractions. In order to get rid of it, we're going to multiply the top and the bottom by the conjugate of the bottom, 2 plus 5i. Now this is okay because really we're just multiplying the top and the bottom by the same thing, so it's like multiplying by 1. In order to do this, we're going to need 2 rectangles and we're going to go ahead and multiply. So again, I want you to pause your video, multiply straight across the top and straight across the bottom and see what you come up with. You got negative 6 plus 43i when you simplified. And on the bottom, you'll notice that we got 29. Our imaginary number went away. When we multiplied our 2 conjugates, in the middle, we got a 10i and a negative 10i. So those are going to cancel out. That's why we flip the sign for conjugates. You'll also notice in the bottom corner, we had a negative 25i squared, but remember, I squared is negative 1. So that's why it turned to positive 25. I'm going to look for any more simplifying I can do here, and these numbers don't have any common factors, so this would just be the final answer. So notice when we're dividing complex numbers, we're really just trying to get the I out of the bottom by multiplying the top and the bottom by the conjugate. Let's move on to objective number 4. In objective 4, we're performing operations with square roots of negative numbers. So the idea here to remember is that the square root of negative b is the same thing as I times the square root of b. Basically, when you have a square root with a negative underneath it, you can pull the negative out in front, but it turns into an I. So for the first example, the square root of negative 25 times the square root of negative 4. Now, one common mistake would be to follow our usual rules for square roots where you can multiply underneath. If you do that, you end up with the square root of 100, which is 10. That's not the case here. You can't multiply 2 square roots of negatives like that. Instead, we first have to pull the i's out in front. So we're going to have the square root of negative 25. Well, we know the square root of 25 is 5. So this is actually just going to be 5i. Now, the square root of negative 4 is 2i, because the square root of 4 is 2, and we pull the I out. When I multiply those together, I get 10i squared, and since I squared is negative 1, we actually end up with negative 10. So you can see the difference there. Had I done it the way I showed you in red, I lost a negative sign. Number 2, we're subtracting square roots. Now, in order to subtract these square roots, they have to be the same underneath. So we first need to see if we can simplify these a little bit. I'm going to change the square root of negative 18. Now, negative 18 is like negative 9 times 2. I'm also going to break down 8 to be negative 4 times 2. Now, if I look at the first piece, the square root of negative 9 is 3i, but I still have that root 2 underneath. The square root of negative 4 is 2i, and again, the root 2. Now that I have common radicals, I can just go ahead and look at the pieces in front. I have 3i minus 2i, and that just turns into 1i. So the final answer would be I times the square root of 2. Number 3. Now, in number 3, we are squaring a binomial. Remember, you can't just square both of these pieces and say negative 1 squared and the square root of negative 5 squared. You have to remember to either use your rectangle to do your multiplying, or you can use the shortcut where this would be a squared 2ab and b squared. Either way will work. Now one more thing I'm going to do before I go ahead and multiply here, I'm going to rewrite this as I square root of 5. So I'm going to pull that square root in front right away, the I in front right away. All right, and now we're all set to multiply. So go ahead and let's multiply. Negative 1 and negative 1 is 1. Negative I root 5. Negative I root 5. Now in this case, we have to multiply I times I, which is I squared, and root 5 times root 5, which is just 5. So that becomes 5I squared. Now we know 5I squared is negative 5. So this turns out to be 1 minus 2I root 5's minus 5. And a little more combining gives me negative 4 minus 2I root 5. Number 4. In question 4, we are going to have to do a little bit of simplifying. Now the first thing I'm going to look at here is this square root of negative 50. Now I know I can break that down to negative 25 times 2. The reason that helps me is because now I can take the square root of negative 25. That becomes 5I. And I still have a square root of 2 underneath. On the top, I see a common factor of 5 I'm going to pull out in front. I'm going to be left with negative 5 plus I root 2 all over 15. And now a little bit of canceling tells me 5 goes into 15 3 times. So our final answer here would be negative 5 plus I root 2 all over 3. The biggest thing to remember is that we don't like to leave negatives under square roots. We're going to pull them out in front and make them i's. The last objective for today, we're going to solve quadratic equations with imaginary solutions. So, if we take a look at this one, we can solve this in 2 ways. The first way to solve a quadratic would be to factor, or we can use the quadratic formula. Now, if I'm going to look at the factoring for a moment, if I multiply 3 times 4, remember A times C will go in the top of my diamond. I'm looking for 2 things to multiply to 12 and add to negative 2. And if I go through and I try this, I don't think there's any combinations of numbers that will work. So in this case, this equation does not factor. Since it doesn't factor, we have to go to the quadratic formula. So let's go ahead and set it up. We're going to have negative b, so we get 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a times c, so 4 times 3 times 4, all over 2a. Go ahead, pause your video, take a couple minutes, and see if you can get this down to look like an answer that we started the previous example with. So go ahead and just simplify this down as far as you can until you get to just a number plus or minus a square root over a number. Hopefully you got to x equals 2 plus or minus the square root of negative 44 all over 6. Let's go ahead and just simplify this the rest of the way. I'm going to start with the square root of negative 44, and I'm going to rewrite that as negative 4 times 11. The nice thing in that is the square root of negative 4 is 2i, and then I have that root 11 still there. And on top, I have a common factor of 2. I'm going to go ahead and factor that 2 out. Now don't forget, when you factor 2 out of 2, you get 1. So we get 1 plus I root 11 all over 6. And a little simplifying here, a little canceling, says 2 goes into 6 3 times. And so our final answer here for this quadratic is 1 plus I root 11 all over 3. Now, notice that this is an imaginary solution. This graph doesn't actually cross the x-axis. These are the imaginary solutions for the equation. Right now, I'm going to give you 2 questions to try. So I want you to answer these questions and be prepared to share your answers tomorrow. Here's question number 1. Find the product. And question number 2, perform the indicated operation. And this is where we'll end our video today.